Hello. Right, this should be my final video. Well, I won't make a promise I can't keep to yet, but this is really just tidying up a few bits and pieces. So once you've gotten used to using this table, and don't forget, using the table, you're not going to get given it in the exam. You also need to have learnt it. But with the answering of more questions, you will get used to the species that you're writing down and also the observations that are required for them. But just want to go about writing how you would formulate writing out a few answers to some of the questions that you're going to be posed. Now, all of those long extended equations that I've done earlier, as I've said previously, they don't need to be learned. You just need to understand the fact that the OH minus NH3 CO32 minus is reacting with H3O plus. You need to be able to form the equation. So, for instance, if you got asked a question, so write an equation to show the reaction of, let me move that piece of paper, it gets a bit confusing, to show the reaction between aqueous copper ions, so aqueous copper ions, so we've got Cu2 plus aqueous, that's shorthand, not allowed to use that in these equations, but aqueous copper ions with dropwise NaOH. So if you're dealing with aqueous copper ions, really you're dealing with that. And if it also wants observations, which normally come hand in hand, typically I always just write the observation beneath the species. So you always want the starting observation with these. So that is a blue solution. And you can abbreviate solution to Sol. That's going to react with sodium hydroxide. And then it goes on to form, so this is where knowledge of the table comes in, copper with dropwise sodium hydroxide. Because it's a 2 plus metal ions always form the 4 water 2 hydroxide precipitate. So it forms that, and it will also form, let me just move that out of the shadow there, form H2O. Looking at balancing that, you can do it from the point of view of think about if it is a substitution reaction. 6 water ligands there. We've only got 4 water ligands in the complex, therefore we need 2 that look like they've been kicked out, not really happened. And then we're going to need to cover the 2 OH minus ligands in the complex there, we need 2 of those. Don't forget the final observation, this is a blue precipitate. And so that's what you'd be expected to provide. You don't need any more descriptions regarding the colour changes. Now, the only other thing that could occur to that question is if the question said, write equations and state observations if sodium hydroxide was added to a solution of aqueous copper 2 ions, dropwise and then to excess. Now we'll see this quite a lot, this dropwise and then to excess. So when you get a question phrase like that, stating dropwise and then to excess, firstly you have to do an equation for that. So you cover the dropwise, just like I have done there. Then you do a second equation, then to excess. Now your excess equation would be starting off with the complex formed at the end of dropwise. Then any changes, you then write the equation based upon that. But for this one, I've done the dropwise one there, to excess. That's what you put, no change in excess. That's because copper doesn't react any further with OH minus ligands once it's formed the uncharged precipitate, the 4 and 2 precipitate. Now, what about this one? This is a very common equation, or very common question. Cu2 plus aqueous plus dropwise NH3 and 2 excess. So firstly, we deal with that one. So we're starting off with copper with 6 water ligands. We're adding ammonia, and we know that dropwise it forms the 4 and 2 water and hydroxide precipitate. This time, because it's ammonia, and it's ammonia that picks up the H pluses, it forms NH4 plus. Make sure you can see that. Yeah. That's lost to go from 6 waters to 4 waters and 2 hydroxides, means we've lost 2 H pluses off the water ligands to form the OH minus ligands here. So therefore, to gain the 2 H pluses, we'd need 2 ammonias, and we'd form 2 of those. The other way to look at it, in the absence of the balancing there, if you know that part, looking at the charge on the left, that's currently 2 plus, the charge on the right is 1 plus. So to balance up the charges, we'd need 2 NH4s, that makes that side 2 plus, but because we put 2 N's in, that means we'd need another 2 N's over here. So that again would be blue solution, blue precipitate. That's our dropwise. Then to excess, when we do this with a practical, at whatever points we will be doing those, I don't know, but we will be at some point hopefully. You have a small amount of the aqueous copper ions in a test tube. You firstly add 2 or 3 drops of ammonia and you get the precipitate. So that's that reaction. Then when you add to excess, we'd use concentrated ammonia, you get a better result with that, but that's still excess. We're still adding lots of ammonia. And we would then add that to the precipitate that's formed. So our next equation for excess begins with our precipitate formed at the end of the dropwise one. Now this is our only example of a substitution reaction now. Ammonia will not extract any more H pluses from that complex. Copper won't release them. Also, ammonia isn't a strong enough base to be able to pull away any more H pluses, any more protons. But what it will do, it will start to kick out some of the ligands there. And this is where, again, from the table, you need to know that in that reaction, it forms the 2 water and 4 ammonia ligands. Doesn't matter which order you put those in. Copper 2 plus, water has no charge, ammonia has no charge, therefore it's 2 plus. Then we need to look at balancing that equation. Now what you can immediately see is we've got 4 ammonias there, we need 4 ammonias there. But then we also need to look at what's being kicked out. We start off with 4 waters there, we've ended up with 2 there, so that means we need to add 2 waters, and then we've started off with 2 OH minus ligands in that. They've entirely been kicked out. And then you can also see, if we look at the charges, 2 plus, 2 minus, no charge overall, and there's no charge there. You also need to pay attention to the species as well, making sure that they balance. But if you've tracked it all across, looked at what's being removed and so on, you're normally quite safe with that. That question could also be Cu2 plus aqueous plus concentrated or excess NH3. Because that's not mentioned dropwise, we don't need to cover that. we've just gone with the aqueous copper and slung shed loads of ammonia into it. So we start off with that. We're adding ammonia. We know that with excess or concentrated ammonia, we form that, and, oh, sorry, 4 there. Had it right first time. 2 waters. Let me start that again. Butchered that. So we form that. Now we just need to look at balancing this appropriately for this one. 6 waters, 2 waters, that means we need 4 waters. And then we've added 4 ammonias in there, we need 4 there. Again, blue solution. And this one is a deep blue solution. And it's just occurred to me that I forgot the observation on the previous one as well. So I'll just go back and do that. Going back to this dropwise and then to excess, because I've already put the observation for the precipitate there, don't have to put it there. There's no additional mark for repeating that. But here we'd need deep blue solution. The only additional one where you could have a dropwise and then to excess, that would be for aluminium. Because aluminium is the only one that will react with an excess of sodium hydroxide. So start off with aluminium. We're going to add sodium hydroxide, so we'll emit out the Na+ ions. Because that's a 3+ metal ion, when that forms the precipitate, it's a 3 and 3. 3 waters, 3 hydroxides. We've got 6 waters there, 3 waters there. That means we need to balance it with 3 waters that have been kicked out, and we've got 3 hydroxides there. We need to add 3 there to balance it. The 3+ and the 3- mean that side's neutral and that side's neutral. Then with aluminium, the observations, once you know the basics, if it's charged and its aluminium isn't a transition metal, so we have a colourless solution. Whereas if it forms a precipitate, we get a white precipitate. So that's the dropwise. And then to excess, we start off with our precipitate from the previous step. We're adding an excess OH-. Then this OH- takes more protons away, so this second step is still hydrolysis. But this is where you've got the choice. In the table, originally it said AlOH4 with a minus, or I always prefer the AlOH6 3-. So I'll go with that one. You can use either. So we've got 3 OHs there, it's gone up to 6, so we need 3 of those. And then we've got 3 waters there, none in there, so the 3 have gotten kicked out there. And we've got the white precipitate for that, and it goes back to a colourless solution. Now we'll do one more, and this is the one that I mentioned a couple of videos ago, that it's disappeared off the syllabus, but you still need to have some knowledge of the complex, and the reaction is also useful as well. And this is aqueous copper 2+ plus concentrated HCl. So we're starting off with that blue solution. With HCl, we don't need to worry about the H in it. So we omit the H plus from the acid and we just show the Cl minus. That's the important ligand. Now, from the introduction to transition metals, copper forms a tetrahedral complex with chloride ions. So Cu, Cl4, 2 plus, 4 minus is there, so it's 2 minus. We've kicked out 6 waters. And then we need 4 Cl minuses. You don't need to put the Cl in brackets because there's only one element there. Doesn't make a difference if you do, in all honesty. But then the observation, I'd be very unhappy if a question ever came up regarding the colour of that, because this should be off the syllabus, but it does form a yellow-green solution. Looks like predator blood out the films, but anyway. So that's the only other one, and I only wanted to mention that just in case you were ever asked about an equation that involves hydrochloric acid, concentrated hydrochloric acid. We always omit the H+. If you did show HCl there, you'd just have to show 4 H plus ions separate as a separate entity in the products over there, but it's better to just omit it. All right. Any questions about any of that, then please email Kath or myself, because I think that's just about covered all of the syllabus regarding transition metals and aqueous ions. Thanks a lot.